This section is all about modeling with equations. And so modeling is always just taking real world situations and using algebra to model the world around us. And so we've spent the last section, P7, talking about how to solve all types of equations. And so we're going to kind of put all of these into a context in this section. So a general strategy, you can read through these steps on your own, but I really want you to pay attention to the first couple of steps. Read the problem carefully several times. So I read with a different purpose every time I read the word problem. The first time, I'm kind of just trying to get a feel for it. What is the situation? What do I know? What do I need? And then the second time that I'm reading, I'm really looking for details and I'm really focusing on the question. The question is going to tell me what I need my variables to be, okay? And step 2 then is asking what are expressions or variables that I need to define for any unknown quantities. That almost always comes from the question, okay? So something that's kind of interesting is like in your ELA classes, you're always taught that the topic sentence comes first. That at the beginning of a paragraph, it should tell you what information is to come in the paragraph. In math, when we're talking about word problems, that's typically the opposite. The question is going to come at the end. And so you're kind of looking at the end of the information for what it is you're trying to find. That's going to tell you what your variables should represent, and you always need to define your variables very clearly because that's going to tell you how to set up your equation. Then the rest of that is just how you're going to carry it out. Lastly, make sure that you check your solution for how you need to answer the question. So very rarely is the answer to a word problem going to be something like x equals 6. You're going to need to answer the question in the context of the problem. So let's look at a few. Number 1 says the bar graph in the figure shows the 10 most popular college majors with the median or middlemost starting salaries for recent college graduates. Now we could estimate based on the bar graph what each of these is, but the scale there is really wide, and so it won't be more than an estimate. But we can use some algebra here to figure this out a little bit better. So it says the median starting salary of a business major exceeds that of a psychology major by $8,000. The median starting salary of an English major exceeds that of a psychology major by $3,000. Combined, their median starting salaries are $116,000. Determine the median starting salaries of psychology majors, business majors, and English majors with a bachelor's degree. So again, I look to the sentence. Determine the median starting salaries of each of these majors, okay? So I need to come up with each of these majors. Now, having 3 different variables makes for a very difficult problem. So I'm going to go back and check and see what information was I given. So it says the median starting salary of a business major exceeds that of a psychology major by $8,000. If I know what a psychology major makes, I can figure out business. And then it says the median starting salary of an English major exceeds that of a psychology major by $3,000. So again, if I know psychology, I can figure out English. So it sounds like the one that I need to describe all of the others is the psychology major. So I'm going to let P equal the starting salary for a psychology major. Psychology major. Okay. So if that's P, then I can use that other given information to define my other variables. Ta-da! Now remember, you can pause the video anytime you need to catch up and copy stuff down or whatever. I'm just trying to keep the runtime short here. And so then we need a relationship between these 3, and it tells us combined their median starting salaries are $116,000. So let's combine them. P plus P plus 8 plus P plus 3 is going to equal 116,000. Now the units here are in thousands. So that's why I don't need to add all the zeros because I'm measuring in 8,000s, 3,000s, 116,000s. So we get 3P plus 11 equals 116, which means 3P equals 105, and when I divide, P is equal to 35. Now again, we need to go back and check. It didn't ask us solve for P. P was never in part of the question at all. So the question was determine the median salaries. P represented the starting salary for a psychology major. So we found that. And now we just need to use the rules over there. So 35,000 plus 8,000 is going to tell me a business major, and 35,000 plus 3,000 is going to tell me an English major. And now we have answered the question. So very simple algebra here. It's just kind of wading through the information and figuring out exactly what it's asking us to do. Okay, let's look at number 2. And we don't need to solve this whole thing. I just want to get it set up. So it says, researchers have surveyed college freshmen every year since 1969. The figure shows that attitudes about some life goals have changed dramatically over the years. In particular, the freshman class of 2009 was more interested in making money than the freshmen of 1969 had been. In 1969, 42% of first-year college students considered being well off financially essential or very important. For the period from 1969 through 2009, this percentage increased by approximately 0.9 each year. If this trend continues, by which year will all college freshmen consider being well off financially, essential, or very important? Now, here's something that's really important. Whenever we use time or years as a variable, we don't want to let the variable be the year. Like 1969 can't be the variable because that would represent the number 1,969. So whenever we use time as a variable, we need it to be a measurement from a certain point in time. And since they started taking this measurement in the year 1969, then the way we would want to define our variable is like this. Let t equal the years since 1989. That means essentially that t equals 0 is the year 1969. Okay? And so that means that we can keep moving forward, like t equals 5 would be the year 1974, because we just add 5 to it. Okay? So what we know then is that the initial amount we started with was 42% of those college students. And then this percentage increases by 0.9 per year. Well, this is a linear situation, okay? So what we have happening is we start with 42% and we add 0.9% per year. Now, we don't need to write this as 0.42 because we're adding 0.9 percentage points each year. So we're just kind of working with that percentage rather than a percentage of something. That's why we don't need to convert it to a percent. And so the question is, in which year will all college freshmen consider it being very important? And so all would be 100%. So that's what we're trying to get to. And so that's going to be the equation that we solve. I'm confident that this is an equation you can solve. And so the solution that we'll get will be t is approximately 64.4 and some change. Now, that means it's going to happen sometime in the 64th year. So let's say by year 65. By the start of year 65, all college freshmen are going to say it. At the beginning of year 64, they won't all say it. Sometime in that year is when it's going to change. That does not answer the question because it says in which year. So we need to take the year 1969 and add 65 to that. And that is going to give us the year 2034. And so that will answer the question. So about 12 years from now. That's not going to age well later on this video, but we're in 2022 right now. So that's where we are. Okay, let's carry on then with some other ones. 3 is another linear question, so I'm going to leave that one for you to look up on your own. Here are some reminders of some common geometric formulas. These might come in handy on some of the problems. Number 4 is a question about perimeter. That's another linear relationship. So I want to go ahead and skip to number 5. Okay, so this one requires the use of a quadratic equation. So it says a rectangular garden measures 80 feet by 60 feet. A large path of uniform width is to be added along both shorter sides and one longer side of the garden. The landscape designer doing the work wants to double the garden's area with the addition of this path. How wide should the path be? Okay, so anything that's geometric like this, I like to start by sketching out a picture of what it's going to look like. So we have a garden in the shape of a rectangle. So here is my garden. Now, what do I know about this garden so far? I have 80 feet by 60 feet in my garden. And we are going to add a path, but we're only adding it around 3 sides. That's important to note because the first time I did this problem, not going to lie, I didn't read it carefully and I couldn't figure out why I was getting weird answers. So the path is only going to go around the 2 short sides and the long side. So it's going to look something like this. Okay. So there's our path. It's only going to be like a U-shaped path that goes around. And they told us that the path is of uniform width, which means all the way around, it's going to be the same width anywhere that I measure it. And that's the thing that I don't know. So that's what I'm going to call my variable x. Now, we want to double the area essentially of our rectangle. I'm starting with the green rectangle, which has an area of 4,800 square feet. And I want my new rectangle, the larger brown rectangle, to have an area that is double that. So basically 9,600 square feet. I want the new area to be 9,600 square feet because that's 2 times 4,600 or 4,800, double, okay? So we need to figure out how to find the area of this new rectangle. Well, I started with a width from here to here of 80, but then I added x on each side. So now that width is a total of 2x plus 80 when I look from end to end. An x on each side plus 80 in the middle, that's 2x plus 80. But going up on this direction, I only have one extra x because I don't have a path on the bottom. So this is just going to be x plus 60 on that side. So that means the area of this larger rectangle is going to be 2x plus 80, that's the width, times the height, which is x plus 60. And we want that area to equal 9,600. This is going to give us a quadratic equation. Now, we don't want it equal to 9,600 in factored form. That doesn't help us. We need it equal to 0, which means factored form is not helpful here. We need to distribute this out. So I can go ahead and do that. And then I need to subtract 9,600 from both sides. And then I also noticed that I can divide everything by 2. When we were just factoring, we had to factor it out because it was a GCF. But since this is an equation, as long as I do it to both sides, I can just divide it out entirely. So I'm going to go ahead and do that. And this actually comes out with pretty nice numbers. If you don't recognize right away that this is factorable, this would be a great one to complete the square. But I do notice that I can multiply 120 and 20 to get to 1,200. And that will work out well to factor. So this is going to be x plus 120 times x minus 20 equals 0. Don't lose the equal 0. So we get 2 solutions, x equals negative 120 and x equals positive 20. Now remember that that value of x represents the width of the path. So negative 120 does not make sense in the context of the problem. So the path should be 20 feet wide. That's the answer that we're looking for. Okay. Number 6 is another one that's just practice using a formula. So I'm going to let you look that one up on the PDF document yourself. Let's look at one that we have to use the Pythagorean Theorem. So remember from geometry, your Pythagorean theorem, a squared plus b squared equals c squared. This one is going to typically introduce a quadratic as well. Number 7 says a radio tower is supported by 2 wires that are 130 yards each, attached to the ground 50 yards from the base of the tower. How tall is the tower? Okay, so what we have here is we want to know, we have 2 wires and a radio tower. So here's our radio tower and here's the ground. And we have 2 wires, 130 yards each. Okay, so here's 130, here's 130, and they're attached 50 yards from the base of the tower. So this is 50 and this is 50. We actually really only care about one of these right triangles. That's all we need. And so the question here is, how high is the tower? And to do that, we're just going to use our Pythagorean theorem. X squared plus 50 squared equals 130 squared. So I'm going to let you go ahead and solve that one on your own. Be careful, if I had a situation where it was like x plus 2 squared plus yada, 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 remember we have to square the first, square the last, multiply and double. Don't lose your middle term when you square a binomial. X plus 2 squared is never equal to x squared plus 4. Remember that. The last example uses a rational equation, and this is the weirdest kind of situation, so I want to make sure that we work through this last one. I know this video is getting a little bit long, but stick with me through this last example. It says a group of people share equally in a $5 million lottery. Before the money is divided, 3 more winning ticket holders are declared. As a result, each person's share is reduced by 375,000. How many people were in the original group of winners? So the unknown person is, or the unknown amount is the original group of winners. So let's let X equal the original number of winners. We're not going to solve this. We're just going to set it up. Okay, so originally, everybody was going to take 5 million and they were going to divide it by the number of people that were in the original group of winners, and they were going to earn some amount of money, okay? But that amount of money got decreased, okay? This is the original amount of their winnings, right? That 5 million divided by X is how much each person was going to win. The problem is that got decreased by $375,000 because the $5 million, instead of being divided by X, got divided by X plus 3. Because now there are 3 more winners. There's one just like this on your homework, so you're going to set it up the same way. So the prize money didn't change, okay? So what ended up happening, the first side, the left side, is what they wanted to happen. 5 million divided by the original number of winners. But the right side is what actually ended up happening. There was $5 million. It got divided by the X plus 3 number of winners because there was 3 more winners than they originally thought. So let's say there was 4 people in the group. They thought they were splitting 5 million 4 ways, but they really had to divide it 7 ways. So 5 million divided by 7, that's how much each person got. So what it turned out is they thought it was going to be 5 million divided by 4, but it ended up meaning that it was 300, 700, whatever that number is, less than what they originally thought they were going to get. So this is what they thought their winnings were going to be, but it ended up being $375,000 less than what they thought their winnings were going to be, because they really ended up having to divide it by 3 more winners. So that's what that equation would look like. And you would solve that equation by multiplying by the LCM, just like we did in the equations that we practiced yesterday. So that is where we are going to stop. It's all different kinds of equations, but it's just a matter of getting the problems set up. These ones like number 8 are definitely the hardest, but there's only one on your homework, and this is not really a situation that's going to come up in your real life a whole lot very often. So do your best, and I will see you later.